How to choose a redundant switch and system configuration, Chapter 4. It's important to understand the key components and configurations of an RSW ODU. The main factors to consider include. It's important to understand the key components and configurations of an RSW ODU. The main factors to consider include component types, such as LNB, buck, LNA, or BDC. Frequency band, options include KU, KA, C, or X bands. Redundancy, you can choose between 1 to 1 or 1 to 2 redundancy. 1 to 2 usually used for a 4-port feed. Where you have configuration, 1 redundant to the 2 active LNBs. TX-RX configuration, decide if you need a receive-only, RX, or a transmit and receive, TX-RX, setup. Connector type, for the modem, you'll need to choose between N-type or F-type connectors. In summary, these are the foundational elements that guide your RSW setup. We'll walk through the key considerations when ordering the right RSW outdoor unit or ODU. We'll look at different options, important factors, and specifications to ensure you make the best choice. First, let's talk about device references. Several factors come into play when choosing either internal reference or external reference: cost-effectiveness, balance performance with budget, integration simplicity, ensure compatibility with existing systems, accuracy levels match to your application's precision requirements, power consumption, opt for energy-efficient models where possible, and the setup environment all impact your decision. Internal reference is more cost-effective since it's often built into the device, for example, oscillators and frequency synthesizers, communication equipment, reducing overall cost. On the other hand, external reference has high accuracy level, precision and stability due to particular oscillator and clock setup externally, which is also ensure the device circuits are isolated, not affected by the accuracy and stability of the reference signal. The 10 MHz external reference is crucial for system synchronization. It can be generated by a redundancy switch or provided by an external source such as a modem or another RF local source such as signal generator and frequency synthesizer. Choosing the right IFL cable length is essential. Available options include 30 meters reduce signal loss and cost, 50 meters, and 100 meters offer flexibility for distant installations, depending on your installation needs. If you need a longer cable to connect to the controller box. Also, you need to consider cable loss matter. Cable length is limited as 100 meters due to Ethernet signal restriction unless extra accessories such as PoE extender to amplify the signal to compensate the cable loss. To cover this topic IFL cable in more detail in the next 2 slides. The AC connector type should match the infrastructure to ensure compatibility and reliability. Power source. Deciding on redundancy is another critical factor. Do you need a redundant power supply? Selecting yes ensures continuous operation in case of power failures. There are different IFL cable configurations. A 1:1 RSW setup includes a bundle with 1 RF cable and 1 Ethernet cable. A 1:2 RSW setup contains 2 RF cables and 1 Ethernet cable. In detail, cable bundles used in 1:1 and 1:2 RSW configurations, along with the specifications for the Ethernet and RF cables. IFL cable bundles. For a 1:1 RSW configuration, the IFL cable bundle contains 1 RF cable, used for transmitting and receiving radio frequency signals. 1 Ethernet cable, used for data communication and control signals between the ODU, outdoor unit, and IDU, indoor unit. For a 1:2 RSW configuration, the IFL cable bundle contains 2 RF cables. This configuration supports redundancy or additional signal paths, ensuring higher reliability. 1 Ethernet cable, used for data communication and control, similar to the 1:1 configuration. Ethernet cable specifications are also important. The Ethernet cable uses an Amphenol PT06E10-6S 424 connector to connect to the outdoor unit, ODU. This connector is robust and ensures a secure connection. The other end of the Ethernet cable uses a standard RJ45 connector, which connects to the indoor unit, IDU. This is a common connector type for Ethernet networks. The Ethernet cable is Category 6, Cat6, which supports high-speed data transmission and is suitable for demanding communication applications. The RF cables in the IFL bundle are designed to handle high-frequency signals with minimal loss. These cables are engineered to ensure reliable signal transmission between ODU and modem. This table shows typical cable type and insertion loss. Lower cable loss is more expensive in cost. It's recommended to use LMR 400 type cable for BUC to ensure full output power is achieved. LNBs are capable to deal with higher insertion loss various types of cables as LNB. Here is a summary showing 10 MHz injection cable specifications, cable type, connector, cable insertion loss for your reference. Start with the 10 MHz insertion loss should be less than 1 dB since external 10 MHz source is usually 0 dBm plus or minus 5 dB while devices, LNB or buck, requires the same level. Speaking of Ethernet cable specifications, we need to be aware of the distance between equipment. Power over Ethernet (PoE) provides a convenient and cost-effective approach to achieve both power and data connectivity on a single connection. However, since it is an Ethernet channel, it's highly restricted by the 100-meter distance limit. Cable length is limited as 100 meter due to Ethernet signal restriction unless extra accessories such as PoE extender to amplify the signal to compensate the cable loss. Thus, the distance between antenna and the system is a concern. Beyond this limit, signals will become indiscernible and distorted. There are two main reasons for signal degradation over Ethernet: wire resistance and interference. Thus, PoE extender is ultra important to achieve long-range Ethernet deployments, which has 100-meter limitation due to signal attenuation as data travels along the cables, result in signal degradation and potential data lost. Speaking of IFL cable longer than 100-meter case, additional things we need to implement with coaxial, for example, a line amplifier. Our RSW ODU supports multiple AC power plug options to ensure global compatibility. NA, NEMA 5 to 15 standard in North America, 120 volt, 15 amp. UK, BS 1363 fused plug for UK/Ireland, 230 volt. EU, CE77 Schuko/French hybrid for continental Europe, 230 volt. CN, Type 1 Australian/Chinese 3-pin flatblade, 220 to 240 volt. AU, AS/NZS 3112 Australian/New Zealand angled blade, 230 volt. IEC, 60320 C14 common for data centers, universal inlet. Select the connector matching your regional voltage and safety standards to ensure seamless deployment. Redundancy power supply is an important option for ensuring uninterrupted operation and high reliability. It allows for load balancing, reduces stress on each unit, extends the lifespan of the system, and provides maintenance flexibility. This is particularly important for mission-critical applications. The dual AC power supply option provides a fully redundant architecture within one controller enclosure. Key features include uninterrupted operation. Dual input AC paths eliminates single points of failure. Load balancing distributes power demand evenly across units, minimizing thermal stress and prolonging component life. Maintenance flexibility enables hot swapping or servicing of one power supply without system downtime. This design is critical for applications requiring 24/7 reliability, such as data centers or industrial automation. Lastly, note that an additional accessory is required. You'll need an additional AC cable for the second power supply port. 2 cables will be used in total and length would be various. When ordering your RSW ODU, ensure you select the right configuration by considering these critical options. IDU, indoor unit. Decide if your setup requires an integrated indoor unit for signal processing. Boom mount. Confirm whether a boom mount is needed for antenna positioning. Transmit reject filter, essential if you need to minimize interference from nearby transmitters. C-band 5G interference solution, mitigates potential disruptions from 5G networks operating in C-band frequencies. Each yes/no selection impacts performance and compatibility. Consult our guidelines to match your operational environment. IDU system is designed with a compact 1U chassis, making it easily mountable on a standard 19-inch rack. This compact design is ideal for installations where space is limited, while still providing robust performance. The system offers remote control and monitoring capabilities. You can access and monitor the system status from a PC through an internet web interface. This feature allows for real-time monitoring and control, ensuring that you can manage the system efficiently, even from a remote location. Overall, the key benefits in using IDU are an LCD status display and an audible alarm with front panel interface. These features provide immediate visual and auditory alerts if a fault is detected, enabling quick response to any potential problems. The boom mount option enables direct mounting of the waveguide switch onto the feed assembly, eliminating intermediate components and reducing signal loss. The key feature is waveguide switch and LNBs mounted directly at feed to minimize losses and minimize impact on G to T radio. Other features include extended cable reach. A longer cable connects seamlessly to the controller box, accommodating flexible installation layouts. Integrated mechanical support. The design includes robust weight-bearing capabilities, ensuring stability even in high-vibration environments. This solution is ideal for applications requiring precise alignment and minimal RF path interference, such as satellite communications or radar systems. This option allows you to mount the waveguide switch directly on the feed assembly, which can be beneficial for smaller antennas, where the RSW cannot be close to the feed. Controller box mounted further away. Speaking of mechanical weight support, there is guideline for the customer. The diagram and screenshot gives you a proper idea of the weight to support to avoid any issues during operation. For references, here is an overview of weight supporting by the boom mount. One of the key benefits of transmit reject filter option, which is available in LNB RSW, is the ability to attenuate signals that could impact the receiver. Mitigate unwanted sign loss and interference from the transmitter. This ensures a cleaner signal and better system performance. Another critical factor is regulatory compliance. The LNB RSW helps minimize out-of-band emissions, ensuring adherence to industry standards and preventing signal interference issues. This leads to improved signal clarity, reduced noise, and a more reliable and efficient communication system. This slide addresses a critical challenge in modern communication systems: C-band SATCOM and 5G cellular networks sharing the same spectrum. This overlap can lead to significant interference issues, which we need to mitigate to ensure reliable service. First, let's talk about the potential risks of this spectrum sharing. The interference can cause a total loss of service due to several technical issues. Gain compression and saturation. This occurs when the receiver is overwhelmed by strong signals, reducing its ability to process weaker signals. Noise floor degradation. The background noise level increases, making it harder to distinguish the actual signal. Unwanted intermodulation. This creates additional, unwanted frequencies that can interfere with the desired signals. To address these challenges, we have developed two key solutions. First, waveguide filter. This component is designed to suppress the frequency content at the interference band. By filtering out the unwanted signals, the waveguide filter ensures that only the desired frequencies are processed, reducing the risk of interference. Second, C-band interference mitigating LNB. This specialized LNB, low noise block, has a high tolerance level for interference. It is designed to attenuate signals at far-field distances, effectively reducing the impact of 5G cellular signals on the satellite communication system. This ensures that the satellite receiver can operate efficiently, even in environments with high levels of interference. In summary, the coexistence of C-band SATCOM and 5G cellular networks presents significant challenges, but with the right solutions, such as the waveguide filter and C-band interference mitigating LNB, we can effectively manage interference and maintain reliable communication services. Let's go over the risks posed by lightning strikes, which can severely damage electronic circuits and disrupt communication systems. Let's break down the risks and the solutions we propose to mitigate them. Risks. Lightning strikes can induce voltage between conductors, driving a surge current into electronic circuits. This sudden surge can overwhelm and damage sensitive components. Additionally, current flowing onto conductors can create voltage across a series of impedances, further stressing the system and potentially causing failures. Mitigation techniques. To protect against these threats, we have developed a multi-layered approach. First, shielding. We use EMI gasketing, shielded cables, integrated connectors, waveguides, and isolators to create a barrier against electromagnetic interference. This shielding prevents external energy from penetrating and damaging the system. Second, shunting energy to ground. Critical component interfaces are protected using gas discharge tubes, GDT, or varistor-type surge protection devices. These components divert excess energy safely to the ground, preventing it from reaching and damaging sensitive electronics. Third, grounding and bonding. We ensure low impedance paths to ground by using the component chassis and bonding all components to common grounding points. This creates a robust grounding system that dissipates energy quickly and safely, reducing the risk of damage. Summary: by combining shielding, shunting energy to ground, and proper grounding and bonding, we can effectively protect electronic systems from the damaging effects of lightning strikes. These mitigation techniques ensure the reliability and longevity of the system, even in harsh environmental conditions. Finally, lightning protection option is crucial for safeguarding your system against electromagnetic pulses and lightning strikes. Mitigation techniques include shielding, shunting energy to ground, and proper grounding and bonding. These measures ensure that your system remains operational even in harsh environmental conditions.